All right, so we want to solve these three trig identity questions. Let's start with the first one which is the easiest one. Now remember, for trig identities, you want to always start with working with your more complicated side. So if I look at these two over here, this side, the left side, is slightly more complicated because it's got a tan cube, whereas the right side has a tan square. So I'm going to work with the left side over here. I'm going to split this tan cube into tan x times tan squared x. And now you can see tan square and tan square match, so that's the reason why I did that. Next, I'm going to convert this tan into sine x divided by cos x. Tan square x just stays the same. And now these two coses just cancel, and you're just left with sine x tan square x, which is basically the same as the other side. So we don't even have to work on the other side for this one. Let's go to this second problem. Slight typo there, that's an exponent for. So if we compare these two, the left side and right side are equally complicated, so it doesn't matter which side you work with. I'm just going to work with the left side over here. So if I want to convert a cos 4 into a sine 4, and I cannot factor each side, cannot do difference of squares or common factor, what you want to do is you want to split the cos 4 theta into cos square theta times cos square theta. Next, I'll use my trig identity where sine square theta plus cos square theta equals to 1. I'm going to use that to replace cos square theta with 1 minus sine square theta, and I'll do that for both of them. And the reason why I'm doing this is I know that when I FOIL out these two brackets, negative sine square theta times negative sine square theta will give me positive sine 4 theta. So I know I'm on the right track over here with doing this. So let's FOIL out these two brackets. 1 times 1 is 1. 1 times negative sine theta is negative sine square theta. Negative sine square theta times 1 is also negative sine square theta. Negative sine square times negative sine square is positive sine 4 theta. These two are identical with opposite signs, so I can cancel them off. So I'm left with 1 minus sine square theta plus sine 4 theta. I know that 1 minus sine square theta is just cos square theta. Again, the same identity, sine square plus cos square equals to 1. Using that identity, I can switch these two to cos square theta, and this is just the same, and now the two sides match. Let's go to the third and final problem. In this problem over here, the left side is definitely more complicated, so I want to start with working on the left side and just simplify it down. Now, this is an extremely hard bracket to FOIL out, so you don't want to FOIL out this bracket just yet. Instead, we can use our identity to convert tan square x plus 1 into sec square x. Next, I want to simplify this bracket over here. So I'll write this the same. Sec square is just 1 over cos square. And on the bottom, I have a tan x. So I could write sine over cos over here on the bottom. So sine x over cos x. You could have also written as cos over sine with the cos on the top. That's the exact same thing. Now this cos and this square will cancel off. I'm left with sine x plus cos x times 1 over cos x sine x. Now I can multiply these two out. So sine x times 1 over sine x cos x is just sine x over cos x sine x, because sine x times 1 is just sine x, denominator stays the same. Same with cos times this, it's just cos x over cos x sine x. Then I can just cancel out the two signs. I'm left with 1 over cos x here, plus can cancel out the two coses, and I'm left with 1 over sine x here. It's basically the same as the other side.